All right. Hello, everybody. I teach this class at noon quite often, and every time I'm like, I wish I could say good morning or good afternoon, because good noon just sounds kind of weird. But good noon to you. So, hello. My name is Sam Snow. So I'm your professor. I know that the listing online's been a little weird, as in nobody listed. I've taught this course a lot since coming here. I'll tell you a little bit about myself over the course of our session today. It'll be a relatively short one, kind of introducing you to the course, telling you what it's about. And this particular section, specifically for the non-environmental majors, is what I have taught the most since coming to LSU 6-7 years ago now. So I hope to have it pretty well organized for you. I am changing a couple things this time around. I'll talk to you about that. So with that, just a quick little bit about me. Yes, you could call me Dr. Snow. I do have a brother named John Snow. I know a lot more than he does because I'm mostly kidding. So anyway, I like to tease him. He's my younger brother, and it's all fun. There's a Game of Thrones reference there in case anybody missed that. So today what I want to do is get to know you guys a little bit while also sharing a little bit about myself so you can get to know me. So what I'm going to do to start, we'll come back to our slides. I've got like 3 or 4 slides today. Before we go into the syllabus, before we go to that, I want to do a little quiz survey sort of thing. What this will do is familiarize you with the software that I use for the quizzes if we do that, or participation. And it's a website called Kahoot, kahoot.it. Probably used it before. It's not all that impressive, but it works. So today, don't worry about, you just add your name there if you want to, or something appropriate otherwise. In the future, I'll have you add your 8-9 numbers here so that I can just track any attendance or grades that I want to that way. Okay, so yeah, just grab a phone, computer, whatever you'd like. Kahoot.it, and then enter that number. I haven't put the Moodle page up yet. I'll talk about that a little bit, but I haven't had access to it yet, so that's why. Assuming I get access to it, I'll try to have that up, the syllabus posted and all that for Thursday. So it looks like most of you are in. I think it'll let you join later as needed. Okay, so we'll begin. So, what's your major? This is theoretically, none of you will be EVEG majors because we have a different section for that. I know a lot of you are civils that have to take this, but we also get some others. Yep, good. So one chemical and one other. Who's the other, if you care? And what? Yeah. B? Okay, cool. Great. All right. How many years have you been at LSU? I've been here since 2016. So I moved here. I spent 2 years in Michigan. I grew up outside of Atlanta. Went to school in Atlanta for basically all of my schooling at Georgia Tech. So I spent 2 years up north and then came back to the south. Was happy to be away from the winters up there. It was quite the contrast. Okay, so most of you are 4th years, a few 3rd years, transferred, a couple others. Okay. How old are you? I'm 35. Turned 35 this summer. Of course, this correlates pretty well with the other one, but okay. Very good. And where are you from? And to simplify this, I'll just say, where did you spend most of your childhood? I already told you I grew up outside of Atlanta. So technically I'd be in the yellow category here, 3 states away, although it doesn't seem all that far. Okay. Lots of locals. All right, so regarding the class, which topic are you least comfortable with? Would it be chemistry, physics, engineering math, or are you pretty much a boss at everything you look at? Okay. As I suspected, the civils usually don't like chemistry, so since that's most of you, and then a couple of you are just like already ready for that A+. Okay, got it. Okay, so I'm gonna have you look at this picture, and it's a little bit of a chemistry quiz here, but what do you think of? Should have given you more time on this. Okay, so 8 of you just straight up hate chemistry. Fair enough. We kind of already knew that. 11 of you were thinking like you got some reasoning here. It's like, oh look, that's iron. Fe is iron. I remember that. And there's an oxygen there, so that must be some sort of iron oxide. Good for you. Good for you. See, a few of you, 6 of you, had taken enough chemistry to realize that's not really a possible chemical structure. So, and it's just really, it looks weird. So great. And then 5 of you got the joke. So it's a Ferris wheel. So if you talk about iron, there it is. There it is. If you're talking about iron, you can have it in a couple forms. Ferrous is Fe2+, ferric is Fe3+. The reason I always remember that, some time ago, my sister got me a little shirt with basically that on it, the Fe2+ all around. It's like, okay, I'll never forget that one again. So Fe2+ is ferrous. So it's a Ferris wheel. You might see one in a state fair. Okay, and on that note, do you enjoy a good pun? You all ready to drop the class now? I guess you just have to pick your favorite, basically. Okay, only 4 of you selected the option that was, I tried to give you an option that was like, no, I don't like puns, but I kind of forced another one on you there. So, I guess, and none of you refused to respond at all. So that's a good thing, good sign. Okay, so I thought those are fun. Sometimes I try to incorporate some humor here and there. You guys are a little better than the 9 o'clock class, who were just kind of sleepy and just got in from the rain. So it was like kind of dead, quiet. Okay, so that's a little bit about myself and a little bit about you guys. So thank you for that. So for the class, this is 3110. This is water and wastewater treatment. Sometimes in the catalog, I think it shows up as just wastewater or something, or on maybe it's the schedule trees. But really, half of it, maybe even slightly more so, will be on the drinking water side. One thing I didn't mention a minute ago is most of my professional background is drinking water treatment technologies. I did get a little bit of wastewater experience while I was in Michigan, and I've developed a little bit about that. But really, a lot of the core concepts we talk about for either drinking water or wastewater treatment are going to apply to a degree to both. So a lot of the core stuff we're learning is going to apply to both. And the way that we'll see the course is scheduled, we're going to deal with primarily physical processes as they relate to water treatment, then chemical processes, and then biological processes. And inherently, wastewater is mostly biological driven. We use microbes to consume all the junk and the waste in the water and process it and use them as a tool. So at a high level, almost all of environmental engineering, and especially water and wastewater treatment, is really about taking the stuff out of some other stuff, or transforming the stuff, or killing it, or something. So if we think about some little vessel of water here, and maybe it's contaminated with a bunch of particles or bacteria or something, what we want to do is send it through some sort of process. Doesn't matter what that process is, we just have some process. And what we want, if we're separating, is to have a cleaner batch of water and then a little pile of these particles, if we're just doing a removal. And we want to do that so that we can take that little pile of particles and stick it into the landfill and then separate that from the rest of the world so that we contain it. That's our disposal. Even a landfill, if you were to take a look at them, requires some water and wastewater treatment because it'll rain on a landfill. There's some leachate. There's typically a collection system to collect that leachate because that's going to be pretty contaminated water. We want to clean that and again take all the junk, probably put it back in a landfill or dispose of it in some other way. We could potentially incinerate, but really in the context of water and wastewater treatment, we want high volumes of water and small volumes of whatever waste product or is maybe just an elimination of the contaminants in it. So whatever we do, we're going to be looking at the math and the kind of the design on how to make a process do that and what are the important features there. So if we're looking at membrane filtration, we might think about, okay, how much of a surface area do we need to pass enough water to get the desired result, and how much energy is that going to cost us? What kind of pressure are we looking at? What kind of pore size does the membrane need to have to prevent viruses or bacteria or whatever constraint we're looking at? How much chlorine do we have to add? How much UVs do we have to shine? How long do we have to let the bacteria grow in order to get our desired removal or treatment goals? So it's really, all of this is going to be in some way or another about conservation of mass. Pretty simple there. Sometimes we will use number instead of mass. For the case of bacteria or viruses, it's a lot easier to count them than it is to weigh them or to quantify their mass. So sometimes we'll be saying conservation of matter. It's probably what I ought to write there. So with that, that's going to drive pretty much everything we do in the class. When we talk about chemistry, I'm going to give you a good thorough refresher of the next couple lectures, catch you back up to speed so we can deal with some water treatment processes with some chemical capability there. But it's really about conservation of matter, even with the chemistry problems. So if you've been annoyed with chemistry in the past, scared of it, intimidated, whatever, if you just hate it, I'm going to do my best to make it a little simpler in terms of, hey, these are units. This is a conservation of mass type of a system. Sometimes we have to compare based on the number of molecules. Sometimes we have to then convert that back into a mass because you weigh it out with a scoop or a shovel or whatever to take physical actions. But we need to know the number because it's the number that will react together. So the overall goals for water treatment are twofold. First of all, health concerns. We want water that's going to be safe. It's not going to cause any health problems. Secondary would be aesthetic. So these health standards in the US, we treat as kind of mandatory. We must treat our water to such and such a degree in order for a public municipality to distribute it. There are no such regulations for private wells, by the way. So if you're on a private well, there's guidance, but there's nobody enforcing it, right? So that's kind of up to the well owner to enforce their treatment or their water quality, which is pretty tricky when the average person that's on well water is not necessarily going to have the knowledge and expertise to do that. But these are really kind of federal standards for public municipalities. Then we have aesthetic. So technically, you could have brown water that's completely healthy to drink. It's possible. Or orange. Maybe you have a little bit of food coloring in your water. Could change the color. You drink brown water all the time if you're drinking any sort of soda or beer, tea, coffee. You drink brownish, mostly water stuff all the time. I mean, alcoholic beverages have some percentage that it's not water, but otherwise it's pretty much water with stuff in it, right? So it's technically possible to have, to not meet aesthetic standards. Nobody wants to drink the water if it's brown coming out of the tap, while it could be safe. But of course, we don't want to do it, so we probably wouldn't do it. So these are kind of guidelines or recommendations. We'll talk more about them as we go. So we'll elaborate on that. But essentially, that's the basis of our water treatment in terms of drinking water. For wastewater, we want to protect intended uses. That's kind of the most broad way to describe it. So if we want to be able to catch a fish out of a stream, river, bayou, ocean, whatever, and then eat it and presume that it's safe to do so, well, there's certain wastewater discharge parameters we have to meet in order to do that. We want to make sure that we're not harming fish by depriving them of oxygen so they die. We want to make sure that we're not overloading a water body with fecal-related bacteria. We'll talk a lot about that as we get to both sides of the water treatment. Most of our diseases are human pathogens that are potentially waterborne. Really, it's a fecal-oral route of transmission. You don't want to eat or drink something's poop, right? Especially not a warm-blooded animal. So we want to protect our waterways for all of these things, and we want for the possibility to have a thriving, mostly pristine ecology environment. Those are all benefits to humanity, and people care about each one of those things. So those are our intended uses. Of course, it's also a good thing that we are able to discharge wastewater, whether that's our sewer or industry. It's an important part of our livelihoods to be able to make use of the environment. So there's definitely a balance there. And as engineers, the way I see it is we have to strike the balance that's optimizing both, right? Because we care about people. That should always be on the top. We care about the fish because people care about the fish. And so we're not elevating wildlife above humanity. I don't think is appropriate, but it is important to be concerned if there's some species that could go extinct by our actions. We ought to take special care because we like, at least some people like to explore all the different living organisms there are and like to know that they could do that. Okay, so that's kind of big picture about the class itself, the topic itself, really. So coming to the class, we have a textbook I'm recommending that you get. It's a great one for introductory level environmental science and engineering. So it does more than just water and wastewater treatment, but the chapters on water and wastewater treatment I think are very helpful. They're at a good level for this class, in my opinion. If you don't want to get it yourself necessarily, you think you would just sell it back at the end of the semester, maybe form a study group and share one between 2 or 3 of you. I think you'll appreciate having access to it. That's my opinion. I'm not forcing anybody to buy it, but that's my recommendation. So I think it would be helpful, and if you ever think you might end up back dealing with environmental systems and having a question to answer, I think it's a pretty good place to start. Okay, so that's, the syllabus will have the text for that too. I'll get that up to you. Talk about it in a moment. You can expect about 4 homework assignments, possibly 5, probably will be 4. First one will be sort of on the chemistry and mass balance and unit operations, not unit operations, manipulating units for the course, dealing with concentration, converting from moles to mass, things like that, just basics, priming you, making sure you have kind of the fundamental skills that maybe you haven't touched in a while ready. Then we'll deal with sedimentation coagulation. We'll have the first exam after that. Then we'll have a section on filtration and disinfection. Have an exam after that. And then the last one will be kind of biological treatment. So that'll be our wastewater. Probably have some quizzes. We'll talk about more in a moment. And let me bring up the syllabus here. Okay, so before I get to the grading structure, I'm going to just walk through the syllabus here. I do have office hours Thursdays directly before this class. Happy to do by appointment otherwise, but I just know that I will be in my office at that time, so that if you swing by before class, that would work just fine. Probably Tuesdays that will generally be true of as well. But I'm happy to meet. Occasionally, I might work from home, like on some days, and I could meet over Zoom if we need. You could always set up time to meet in person here, though. My office is basically upstairs. If you're familiar with any of the civil engineering stuff, we have one hallway that's kind of most of the offices for civil and environmental, just in that office on the 3rd floor. There are a few supplemental books I'm recommending here. I wish that this one was available online. It is not to my knowledge. The ones I'm recommending and I'm posting up here just are not as good quality, in my opinion, for kind of taking it from sort of a basic level into slightly advanced topics for this specialized treatment technologies and things. So if I could have, I would have selected one of the other ones. I just don't like them as much, don't like the problems and all that. But they're there if you want additional resources. By all means, take a look. Objectives are pretty straightforward for the course. I want you to be able to do the appropriate calculations to design different water and wastewater treatment operations. We talked about a moment ago, removing stuff, transforming stuff, separating stuff. What kind of math goes into that? I want you to be able to develop over the course the ability to take a look at a system and say, oh, I will take this approach and then I'll rearrange this equation or whatever, and I can get an answer that allows me to meet that design criteria. And so that's really the intent. And in doing so, we'll talk about all these different components of typical water and wastewater treatment. Okay, so the grading here, I'm actually changing this from all the times I've done it in the past. You guys obviously don't care too much what I did in the past in a sense, but I'm going to explain that because the way I've taught the course in the past, since I'm making a change that's associated with the grading, I want to make you guys aware so that if you are feeling like I haven't prepared you well enough, or I'm counting the exams too highly or something, my aim is to make this change to adapt my teaching style to this change. And the change is that I'm no longer going to emphasize homeworks as much, so I've dropped it down to 50 instead of 100 points, in part because I'm going to just grade them for completion. So your homeworks, I'm not going to care if they're right or wrong. The reason I'm doing this, and I feels a little bit like a soapbox, but I want to explain my grading theories to you. I want to grade you based on how much you learn. So in the past, with all my my homework assignments up. Solutions are available somewhere online, Chegg or whatever. It got to a point where it was pretty clear that people were just copy pasting from some answer sheet. At least 80% of the class or something was probably making some use of it. And what I wanted was for students to challenge themselves and try it without that, right? Because I think that will help you learn better. And then the grades would turn out that the people who were learning less were getting better grades because people were trying it without help of external stuff, wouldn't always get the right answers. So I'm doing this, you're getting essentially less credit in the grade sense, but it's a little bit free. So I would definitely encourage you to only use these alternate homework solutions as a supplement to learning rather than while you're working on the assignments themselves. I'm not going to care so long as you show me you tried and you highlighted your answer. Okay? That's what I'm going to look for. You have to show me that you have an answer, and you have to show me that you had work for the homeworks. Okay? So this is my effort to bring the grades closer to measuring you based on how much you learned rather than anything else. Class participation, I also bumped down to 50. And my plan is each time we have a homework due, I'm going to give you an in-class quiz that makes you perform some of the homework type of problems. Probably be different, just like the exams probably be a little different than the homeworks. The whole point is to help you to see, okay, how much am I struggling here with the actual problems? Did I learn this stuff? I'm going to ask you to do a similar problem, but do it here sitting in class. Okay, so expect that when those homeworks are due, we'll have a little quiz. Okay, and then I'm also probably going to do just generic class participation things, give you little quizzes, kind of like the Kahoot today, but maybe topical questions, or if I give you some sort of a reading assignment, and I'll probably give you most of the credit just for being here and participating in that, and then some partial credit for, like maybe the last 10 or 20% of that grade. I could count off if you got the answers all wrong for the reading assignment. So it will be an incentive to participate because I think by participating, you're learning. Okay, so that's the deal about grading. Any questions, by the way? And feel free to stop me at any point. Okay, so exams will be pretty straightforward. We'll have them in class. Talked earlier about the first one will kind of be on the physical processes. Second one more so the chemical processes, probably include the membrane filtration. The last one will be biological, but so that last section, you'll see in a moment, it's kind of a short section. So what I'm going to do is take the final exam and be partly comprehensive. And the course kind of builds on itself anyway. When you learn how to do a first order reaction in one container, it doesn't matter if that's a disinfection container or a wastewater container that's using bacteria. It's the same principles are at play. So it kind of makes sense that it's going to be comprehensive by nature. Okay, I will get a Moodle page up as soon as I can. My aim is to have that before Thursday. I hope that I will have access to it before then. I'll post this syllabus and the couple slides that we're going through today there. And I will also have you upload your assignments, your homework assignments there as a way for me to kind of manage that. We can go paperless. That lets you keep your own paper copy because we'll go through the solutions to the homeworks after you turn them in. We'll turn them in online, then you'll have them. You can kind of write your own notes in your own homework assignments. Okay, so talked a little bit about it, but here's the overall tentative schedule. As you see, we'll be going through kind of units, mass balance, chemistry, reactions and reactors. Then we'll get into essentially drinking water treatment with sedimentation, flocculation. And our first exam will cover kind of those basics of reactors, reactions, and then coagulation, flocculation. Okay? That'll be the first, essentially the third of our class. I'm going to do my very best not to change the exams, by the way, the dates, unless a lot of you early on are like, hey, we've got 3 other exams that day. Can we move it? And then I'll see what I can do. Okay, so check that early. I don't want to make any changes like a week in advance. Unless something crazy is happening, really not gonna do that. So check your schedules on the early side, and I'll be happy to work with you. Okay, so then we're going to go into some filtration, disinfection, and then the exam, exam 2, and then on to wastewater, and we've got Thanksgiving break. Let's see. I don't think I meant to include the Tuesday there, but I'll look into that. I don't think I did that for my other class, but we'll see. I think I updated this exam time. That's tentative also because LSU sometimes will change those, but that should be our final exam period. That would be Wednesday, December 7th, 10 a.m. to noon. But we'll check that later. So definitely use LSU's website. We'll talk about that as it gets closer. All right, any questions on the syllabus? Okay, so I think that's about all I had for you today. That way we can focus in on the course topic next time, sort of the units review and chemistry. All right, have a good day. We'll see you on Thursday. Oh, you know what? One more thing. I'm sorry. I meant to tell you about the... I'm actually live streaming and recording these lectures. I expect you to participate in class. But if you're sick or you had to travel for something, you are able to attend there. And I plan to post them online, the sessions, so you could use that as an exam review as well. So, but I do expect in-class participation and for you to let me know if you can't. Okay? All right, that's it. Thank you.